let's begin with a new topic. Relation between rotational kinetic energy and MI. MI means moment of inertia. Alright, again we go to the system which consists of n particles. Okay, n particles. सामने देखोगे फिर बोलोगे नहीं तो समझ में नहीं आया. सामने देखो, there is a body which contains n particles and n particles containing mass m1, m2, m3 and mn. Alright, and corresponding distances जो है ना axis of rotation से लिख रहा हूँ r1, r2, r3 and rn. समझ गए? So their corresponding velocities v1 will be r1 omega, v2 will be r2 omega, v3 will be r3 omega, okay, r3 omega and so on, and vn क्या हो जाएगा? rn omega. ठीक है. So kinetic energy is involved with each particles. Let us write K1 will be half, कितना होगा? Half m1 v1 square, m1 v1 square. So कितना हो जाएगा? Can we tell? v1 की वैल्यू रख दें तो half m1 r1 omega whole square, which is half m1 r1 omega square. Similarly, what will be K2? Half m2 v2 square, which is half m1 r2 omega whole square, which is half m1, and here also square and r2 square omega square. Similarly, K3 को यहाँ सीधे लिख देता हूँ half m3 r3 square omega square. Correct? So like that I can write for Kn will be half mn rn square omega square. Is this clear? So total energy of the particles or rotational kinetic energy, so final rotational energy we will call rotational Ke would be how much? K1 plus K2 plus K3 and so on plus Kn, which is same as half omega square, and सबको जोड़ दोगे तो यहाँ क्या लिखोगे? m1 r1 square, m2 r2 square, m3 r3 square and so on plus mn rn square. Is this making sense to you or not? No answer. So my rotational Ke is becoming half omega square sigma mi ri square, and I belongs to 1 from 1 to n. And this parameter, as I told you, what this parameter stands for? आप बताइए जुरियान. What is this parameter stands for? Sigma mi ri square from 1 to n. आप बताओ. The whole parameter, what is it known as? आप बताओ. Moment of inertia. Moment of inertia I, half I omega square, and I had explained earlier that I is nothing but I is known as moment of inertia, moment of inertia. रोटेशन एज ए चैप्टर आई एम टेलिंग यू, जब तक तुम 3 से 4 बार रिवाइज नहीं करोगे आपके समझ में नहीं आएगा, और कहना मानो तो सुखी रहोगे, बाकी आपकी मर्जी। mi ri square, बिकॉज टर्म्स आर ऑल इंटररिलेटेड, इंटरकनेक्टेड, और जब तक आप उसको विजुअलाइज करना नहीं सीखोगे आपके माइंड में वो चीजें बैठेंगी नहीं। हाफ आई ओमेगा स्क्वायर इज नथिंग बट rotational kinetic energy, rotational ke. This is how this formula is achieved or derived. Next is radiation of gyration. I had already explained. Have you understood this? Again, I will repeat a bit. Radiation, radius of gyration. So fundamentally, सपोज हम किसी भी बॉडी को किसी पर्टिकुलर एक्सिस पे रोटेट कर रहे हैं, लेट अस से हियर इज माय बॉडी एंड हियर दीज आर पार्टिकल m1, लेट अस से m2, लेट अस से m3 एंड देन mn, बीच में और बहुत सारे पार्टिकल हैं, एंड देयर वर्टिकल डिस्टेंसेस आर r1, r2, r3 and rn. Okay, so obviously as I told you my I is m. Now I am assuming that each particle, okay, having same mass. Okay, m1 equal to m2 equal to blah blah mn equal to m. ठीक है, all particles are having same mass. So what will be the case? I, moment of inertia would be m r1 square, m r2 square, m r3 square and so on, and lastly क्या लिखोगे? m rn square. Okay, so we can easily write something like m and then r1 square, r2 square and so on, rn square. If I multiply this whole thing by, let's say I write here m times n and then divide by n here. Okay, so m times n will be what? The entire body mass. Yes, so capital M, and here I can write r1 square plus r2 square plus blah blah plus rn square and then divided by n, which I can easily write I as m k square, where k is known as radius of gyration. So k is nothing but so we'll get k square as r1 square, r2 square, blah blah rn square upon n. So k की वैल्यू क्या आ गई? स्क्वायर रूट, राइट? So we can say square root r1 square, r2 square, r3 square and so on plus rn square divided by n. This parameter is known as radius of gyration. K is known as radius of gyration. Is this clear? So radius of gyration is the equivalent distance as if the entire mass is concentrated at that point, which is k distance away from your axis of rotation. So this is how you can understand this whole concept. Perpendicular axis, I had already explained. So let me just go through the perpendicular axis, theorem of perpendicular and parallel axis. Have you understood on the other day? So we can skip that. Moment of inertia of a thin circular ring. You can try few of them. Let me just go through a few of them and then you can remember. Moment of inertia. So moment of inertia, let us say एक circular ring का निकालना है हमको. Circular ring. So circular ring को कैसा imagine करें? Circular ring would be like this. Okay. And जो थिन सर्कुलर रिंग है उसका रोटेशन जो है ना हम यहाँ पे कर देते हैं. ये जैसे ये सेंटर है इसमें कर दिया हमने रोटेशन, ऐसे ऐसे रोटेट कर रहे हैं, माने लेट्स से समथिंग लाइक दिस. तो सेंटर पे यहाँ पे हम रोटेट कर रहे हैं ऐसे. ऐसे. और ये मेरा रेडियस है r. तो हम कैसे निकालेंगे? हमको सबसे पहले तो इसका एक छोटा मास क्या चाहिए, dm, dx डिस्टेंस ले लीजिए. ओके. सो लेंथ ऑफ द रिंग क्या है? लेंथ ऑफ द रिंग. लेंथ ऑफ द रिंग कितना हो जाएगा इस रिंग का? गायत्री बताओ. Length of the ring will be 2 pi r because r is the radius. Okay. And if total mass is capital M, then unit length mass कितना हो जाएगा? Mass of unit length. Mass of unit length हो जाएगा capital M divided by 2 pi r. And mass of dx, mass of dx लेंथ. तो क्या करेंगे? मल्टीप्लाई कर देंगे. तो मुझे क्या मिल गया? dm. dm इज m बाई 2 पाई r इंटू dx. क्लियर? सो मोमेंट ऑफ इनर्शिया ऑफ स्मॉल एलिमेंट, मोमेंट ऑफ इनर्शिया किसका? ऑफ स्मॉल एलिमेंट dx क्या हो जाएगा? di. यस और नो? dx का क्या होगा? di. एंड di विल बी dm इंटू आर स्क्वायर. dm इंटू आर स्क्वायर. ओके. एंड dm की वैल्यू लिखो m अपॉन 2 पाई r इंटू आर स्क्वायर इंटू dx. एंड di को इंटीग्रेट करो. सो इट विल बी लाइक दिस. सो I वुड बी mr अपॉन 2 पाई एंड dx का क्या हो जाएगा? x. ओके. और इसको इंटीग्रेशन कहाँ से कहाँ तक करोगे, इंटीग्रेशन 0 to 2 pi r, बिकॉज एंटायर रिंग लेना है हमने ऑफ dx, सो इट विल बी mr अपॉन 2 pi टाइम्स, और ये हो जाएगा x, dx का x हो जाएगा 0 to 2 pi r। ये आप सीख लोगे तो आपको मोमेंट ऑफ इनर्शिया इजीली निकालना आ जाएगा, mr अपॉन 2 pi, और ये हो जाएगा 2 pi r। ओके, सो ये हो जाएगा mr स्क्वायर। सो I मोमेंट ऑफ इनर्शिया ऑफ ए रिंग that is revolving on its central axis will be mr square. Is this clear? Similarly, आप इस रिंग को डाया के अलोंग घुमाओगे तो, सपोज मैं एक केस ले लेता हूं, mi of the ring about any diameter, about any diameter, तो कैसे निकालोगे, कौन सी थ्योरम लगाओगे? सपोज ये आपका रिंग है, ओके, एंड आपके ये डायमेट्रिकल एक्सिस है ऐसे, और आपने इसको यहाँ ऐसे घुमा दिया डायमीटर के पे, और इसको नाम ए बी दे दिया और इसको सी डी कह दिया। ओके, सो डायमीटर ए बी, दो परपेंडिकुलर डायमीटर हैं, ए बी एंड सी डी। सो आपका, एंड सपोज ये आपका एक एक्सिस है, लेट अस से दिस इज योर okay, understood or not? So this is your 90 degree. So how would you respond to this? If मैंने तुम्हें पिछले लेक्चर में थ्योरम सिखाई थी, and that was theorem of perpendicular axis, right? So what was the theorem? I AB plus I CD would be I YY. Do you remember? हाँ, YY dash, because that is your axis. So this is how. So what will be that? It's the same as, let us take, so we can take as दोनों का तो सेम ही होने वाला है. लेट अस से I diameter plus I diameter is equal to I YY, and I YY dash was what? MR square. अभी अभी किया था हमने. So twice ID would be this. So ID would be half MR square. That means if we rotate about the diameter, the rings MI would be half of what it was earlier. Okay. Now, can any one of you do the third scenario? Suppose this is your ring, okay, and you take axis as this, okay. So obviously you are rotating it like this. So can you tell me what will be the new mi? Any idea which theorem we would use? Theorem of parallel axis. Can you use it? Your axis is here, so it would be one of the dia. पहले वाला तो सेंटर पे रोटेट कर रहे थे, दूसरे वाले को डायमीटर पे रोटेट कर रहे थे, एंड थर्ड जो है यहाँ कॉर्नर पे ऐसे रोटेट कर रहे हैं, एज इफ दिस होल थिंग इज लाइक दैट, like this. Okay, so here you can utilize there are two parallel axes. Clearly you can name them as E, F, possibly write it C, D, O, and this would be your R. Okay, so what did I tell you? Moment of inertia I is mi, moment of inertia about diameter CD plus mr square. This is how I explained you the theorem. So about diameter it will be half mr square plus mr square. It is 3/2 mr square. Okay. ठीक है. So that is how you have to learn. I think in your book there is a list which is given. You must try to do a lot of work on moment of inertia. Each one of it you should try to know how this formula has come for your own knowledge sake. Similarly, you can calculate moment of inertia of a disk. Okay. If we take moment of inertia of a thin uniform rod, how would that be? Moment of inertia of a thin uniform rod. चलिए, how will you envisage a uniform rod? रोड तो सीधा डंडा ही होता है ना, तो कैसे दिखोगे? हैं? मान लो ये तुम्हारा, अच्छा दो तरह से हो सकती है रोड भी, एक तो आप सेंटर से घुमा रहे हो या एक कोने से घुमा रहे हो. ओके, सो दोनों में अलग अलग आएंगे. ओके, सो so if you see that there is a rod which you are actually rotating like this, there is a rod like this, yes or no? रोड ऐसी ही होगी ना. इसको रोड को यहाँ ले लीजिए और ये तुम्हारा सेंटर एक्सेस हो गया y, y डैश. Okay, so what will you do? Let us say this is 0, this is L by 2 here, and this will be L by 2. You will see this is L by 2. So this is L by 2. Okay. So what shall we do? We will take a small dx and this distance as x. So what shall we will actually get? What we can suggest you is that first calculate on the right side and then double it. या तो ये कर लो या फिर आपकी इंटीग्रेशन लिमिट माइनस एल बाई टू से प्लस एल बाई टू ले लो. देयर कैन बी टू वेज टू डू इट. ओके. So I would, what will be my di? Di would be mass. What will that be? M upon L will be unit mass. Okay. Into dx, that would be your dm. Okay. So मैं यहाँ लिख रहा हूँ dm as m upon L dx. Okay. Into x square, that would be my di. Okay. So what would be I? I would be, let me take a limit, minus L by 2 to L by 2 m by L x square dx. Okay. Have you all understood this? Yes. So here you will take it m upon L. This will become x cube by 3, and your limits would be negative L by 2 to positive L by 2. You understand this? And just put the value m upon L. This will become L cube upon 8 times 3, और माइनस माइनस प्लस हो जाएगा L cube upon 8 times 3. m upon L ये हो गया ट्वाइस L cube upon 24. So 2 से ये काट दो 12. So you will get ml square upon 12. So that's your I moment of inertia of a rod whose axis of rotation is going through the center of the rod. Is that clear or not? So I have given you enough number of examples, application oriented, which will make sure that your moment of inertia topic should be very clear. Now if you go back home and do a lot more work on whatever I have taught you, you will be in a better position to understand the topic in a clear manner. Otherwise you will forget it very soon. Okay. So let me close this issue.